Hello friends, welcome to Java threading tutorial. In this video, we will see how to use callable task. You will learn callable task, callable interface, how to use the call method override, then how we can use future object to collect the return value. We know that runnable tasks run in a thread and does not return any value. So we saw that multiple times in our previous videos, and it does not return any value, the runnable task. The callable task also runs in a separate thread, but it can return a value. So to the calling thread context, the callable task will return a value. So this is also a threaded task, and there will be a start and thread will end after the execution. A thread will run this and it will be a parallel task. There will be other threads also, main thread or some other thread. Like a normal thread, this is also the callable task is also a threaded task. In runnable task, we will use run method. Here it will be the call method override. And towards the end, the method will return a value to the caller. We know that runnable class should implement run method. A runnable class in the sense a class that implement runnable interface. So such a class should implement or should override the run method. The same way, callable task should implement the call method with a return value. So the run method, we know it's a void method, it will not return any value, but the call method will return a value to the caller. And this is also a override, and the class will implement the callable interface. When we use executors, we call execute method for the runnable task. We saw that previously, right? We used the executors. One is a cached pool executor and another one is single threaded executor. In both the case, we used the ticker task, which is a runnable interface based task or runnable task, and we gave that task to the executor using the execute method. For callable task, we should call the submit method. So when you are using executor, execute method is for runnable task and submit method is for callable task. Callable task will return a value that we saw here. It's also a threaded task. There will be start and end. Towards the finish of the thread, it will return a value to the invoker. Since call method of callable interface can run in a separate thread, to make use threaded execution, return result is received via something called future object. Since call method of callable interface can run in a separate thread, to make use of threaded execution, return result is received via future object. So if it is a normal execution, let's state that this is the line of code, and here you are making some call ABC method, normal method, and let's state that this method returns a value, say integer. That means when the code executed here, then it comes here and makes call, and the execution will wait here, and once it returns integer, that can be stored, and then execution resumes to the next statement. Here the call will be blocked here. The execution is transferred to this function. The function will execute and it will return an integer value. The integer value we will store in some other variable, or we can pass that to some other function. Alright, but what we want to talk here is, if this is a thread, let's state that this is a main thread. The main thread will wait for the execution of call ABC, and the function will be executed in main thread context itself, right? Because the execution will be transferred to this function, and the thread is still the main thread. Then it will come out and main thread continues from here. That's how the normal function call works. But when we talk about the callable interface and call method, since that executes in threaded environment, and let's state that the call method is returning an integer, main thread is executing here. So after invoking the call ABC, main method will move to, or main thread will move to the next line, and execution continues, and in parallel execution goes here as well. But towards the end it will return a value, right? Who will collect that value? It's not a blocking call here, right? So that's why here we are talking about something called future object. The future object, as the name suggests, tells that result may arrive in the future as a result of asynchronous execution. So that's why we call this as a future object. So the future object will act as a placeholder, and we state that the placeholder will be filled later by a parallel running thread on some other thread context. So once that thread finishes, that will fill the return value in this future object. One can get the return value of the call method. So that's the override, right? When you use the callable interface, you have to override the call method. Call method will get executed in a separate thread context. Call method will return a value, and call method, once one can get the return value of call method via the future objects get method. Here we are talking about future object, right? And using the get method of the future object, we can examine the result, or we can retrieve the result. Let's state that this is a callable thread. Some other thread, say there is a main thread which invokes the, or which starts the thread. Let's state that here it will start the thread. The code for the thread will be placed in the call method override. So this is the callable thread. Thread execution will flow by executing the statements here, and at one stage the callable thread will finish its job. So it ends at some stage, and we know that this callable thread will return some value, right? So we call this as a future object, and when main thread is starting, it provides this placeholder, and the thread execution continues. And towards the end, what happens? The thread will fill this placeholder with the return value. Alright, so initially future object will be empty, execution goes, and towards the end the future object will get filled. And let's state that since here we are talking about main thread, right? Main thread also runs in parallel. Let's assume like this. And main thread what started the callable interface, and let's state that main thread also have access to this future object. Since it started the thread, it will have the thread handle, and it will have this future object as well. So once towards the end the object is filled. Let's state that this is where we started the thread. Main thread continues working on some other task. So at certain stage main thread will make a call to the get method. So this will read this content whatever is filled by the callable thread. So let's state that this is the timing diagram. So in that timing diagram, callable is started here, callable is continuing, and it will get filled at this stage. It will means here the future object will get filled at this stage in main thread's timing diagram. Here it is ending, right? So it will get filled at this stage. So if you call get at this stage, you will be seeing a valid object here. But if main thread tries to call get here, the future object is not yet ready, because at this stage the thread execution is not completed and fill doesn't happen here on the future placeholder. So that's the use of get. So when the object is ready in the future, main thread will make use of the get method and retrieves the value. The get is a blocking call, however. Suppose, as we stated here, if main thread is making call to get at this stage, it will wait till the future object available. Once it is available, main thread will collect the object and continue from here. So this is the blocking period in main thread's lifetime. So if get is called before the future object is ready. So the get is a blocking call, and when it is ready, the call will return. You can also use a timeout on the get method. Suppose if for some reason if this thread is blocked or deadlocked, the future object will never return to this placeholder, and this wait period will keep on growing, or main thread will be blocked, right? So to avoid that, you can use the timeout on the get method, right? So that method will raise the timeout exception. Say for example, if you set a timeout exception of 3000 millisecond or 3 second, the maximum expected delay is 3 seconds here. So state that you are making call to get method to collect the future object, and as already stated, it's a blocking call and the blockage will happen for 3 seconds. Till the 3 seconds, if this future object is not filled, then main method will throw the exception stating that a timeout occurred, and you can handle that exception and decide the workflow, I mean the execution flow. So you can also use the isDone method. The isDone method will tell that the callable thread finished its duty, and if isDone returns true, that means the future object is available. The isDone method returns immediate, it's not a blocking call, saying result is available or not. Alright, now let's talk about the example. In this example, we will use existing ticker runnable and create a new callable task. So we are going to use both runnable. Runnable task will not return any value. It will do its duty in the background silently. And callable task will do the task, and after the task is finished, it will intimate the invoker of the thread with a return value. So here in this example, we will use the existing ticker runnable. That means it will periodically perform a tick on the console output window. Then we will create a callable task to perform summation of a number. So it's also like a tick, but if you state 3, ticker will produce 3 tick, 1, 2, 3. Summation will do the same, but it will perform the summation and returns this summation result to the caller. So that's the difference. Here we will study how main thread spans 3 ticker tasks after starting few callable summation. So here we will make use of the callable task because result will be available in future, right? After making call to callable, we will span some ticker thread, and after spanning the ticker thread, we will come back and revisit our future object to examine the value returned by the callable summation. The main thread waits for the summation task's result and prints it via future object. So after starting the summation task, it will do the duty of starting the ticker as well. After spanning the ticker thread, it will come back because previously it started the summation, right? It will come back and check the future object for the result. So if the summation is still going on, it will wait for the summation to complete, collects the result from future and prints it. So that's what we are going to create in this example or in this video. Here you see this is our runnable task, and we named this as a ticker. We have a name and end, and in the constructor we initialize the internal member end as well as name. We saw this multiple times in this sub-series, in this threading series. Next we have a run method. Run method will run from 1 to end, whatever you passed here. So up to that. So if you passed 5, it will run from 1 to 5, and it prints something in the console window with a delay of 500 millisecond or half second. Right, that's the runnable task. And if you see, since we override the void method, I mean the run method, it does not return anything to the caller. So it's a background task, we can say, and the task goes silently. It will not return any value. Next we have a callable task. So from concurrent we are importing the callable. Then we create the class summation implements callable of integer. Right, so it's not a runnable task, it's a callable task. So it implements callable, and integer is the generic. Callable is a generic interface. So using this generic, we are stating that it will return an integer type. Here we have an internal member sum2. No need to initialize because we have constructor. In the constructor we take the end and we initialize our internal member through the constructor. Sum2 is end. And if you see, this time since it implements the callable interface, we are overriding the call method, and the call method returns an integer, throws exception. Alright, so that's the override. And inside, if you see, we are initializing the sum. We state caller started, caller ends, and in the console window we can see that with the output like this: someone started, someone ends. Right, so this is the message returned by the callable thread, we can state. And in this example we have two kind of threads. One is runnable thread and another one is callable thread. Runnable thread will run silently. Callable thread towards the end will return a value to the caller. And like runnable thread, it can also print some status message in the console window, and that's what we are doing here. Then if you see, we are forming a loop. That loop runs from 1 to sum2. Sum2 we are deciding during the construction of the callable thread itself. So it runs up to sum2, performs the summation. The sum will be, or summation will be in this variable sum. Finally we are returning this sum. So that's the difference. After finishing the task, the callable thread returns a value to the caller. But main thread, if you see, let's state that this is the main thread. Main thread is making call to this call method via the threaded call, and main thread will not wait. It will keep on executing the main thread's code. Right? If it waits here on this call, it will collect the return value, this integer. But still, since it is keep on going, it will provide a placeholder, and later it will examine that placeholder. So if this is the placeholder, main thread at later stage will come back and refer that placeholder. All right, now we have the callable thread. Let's see what main thread is doing. Here in the main thread, if you see, first we create the future object. So future of integer is sufficient, but here we are going to run multiple callable threads, more than one thread. So let's state that if we are going to run 25 callable thread, then 25 callable thread will return 25 value. To collect those 25 value, we need a placeholder, or 25 future integer we need. That's why here we are creating a linked list of future integer, and we call that as a result list, and here we are creating the object. So the result list here is the placeholder. Next, we are using the executor service, new cached thread pool. So here we are using the thread pool. So it's not a single threaded execution, it's a multi-threaded execution, and all execution will go in parallel. We are not creating the separate thread, we are giving that duty to the executor service itself. Then we are spanning a loop, or we are forming a loop that runs 1 to 7, or 7 times it will run the loop. And in the loop, if you see, we are creating the summation callable task, right? We are spanning it callable task. Then system.out.println, submitting summation task for sum. Here we are printing an informative message, right? Sum of I, summation task. Then result list dot add executor dot submit. Here we are not making call to execute. Why? Because it's a callable task, right? So instead of execute, here this time we are making call of submit, and to this submit we are providing the future object. And if you see, I mean the callable thread. So here we already created our callable thread, and here we are giving that callable thread to our executor service method submit. So submit expects a callable, and executor dot execute expects a runnable. So here, since it's a callable, we provided the callable instance which we already created. Now the executor service will take care of running the callable task in a separate thread. In a separate thread, in the sense, let's state that here it is spanning a thread thr, and this thr will make use of the call method and run that in this thread's context, and this thr is spanned by the executor service. If you see, this executor.submit task will run the callable task, right? And we know that this callable task will return a value, and that return value we are adding it to the result list.add. If you look at result list is a collection of future integer. So result list.add means we are providing the placeholder of this future, and that will get filled later when this call method finishes. Here, if you look at create thread pool and submit task, here we are making call to callable, right? And in there's a specific code snippet, create executor and perform counting task or ticking task. So this we saw multiple times, executor service thread pool, new single thread executor, just like the previous one, and this time we are running 3 times. And inside, if you see, thread pool.execute new ex06 of ticker. So this is our runnable task, right? And this one is our callable task. So Whatever you are seeing here is get executed in main thread context. This is also main thread context. So main thread is spanning 7 callable tasks and here 3 runnable tasks, and all will run in parallel. So this is the flow, right? First it spans callable task. Next it spans 3 ticker tasks, and when it is spanning this ticker task, the callable tasks are executing in parallel, right? So it comes back here, and the main thread comes back here and checks the future object. So result list, this is our collection of a future object. Dot iterator will retrieve the iterator for this collection. Using this we can iterate over our future of integer. Iterator future of integer itr dot has next, and here we will examine our future object. If you see itr next get, that tells the future object is ready. It is a blocking call, and if a future object is ready it will immediately return, otherwise it will wait. Here we are not using any wait timeout. If you need, you can do that as well. So it will wait for the future object. Once the summation is ready, it will print the result here. So alright, finally we are shutting down our main thread. Thread pool is here. What about, okay, here we are not maintaining any pool. It is good practice to maintain a pool and shut down when all the tasks are ending. Alright, now let's go back here. So we have main thread, right? Main thread is running here, and when main thread is running, it is spanning 7 callable tasks. So if you see here, at different interval it spans callable task C1. So there are 7 callable tasks it is forming, and summation, if you see, we are passing I, that means it will perform summation of 1. This will perform summation of 1 plus 2. This will perform summation of 1 plus 2 plus 3 up to 7, right? And since it is making call to these callable threads, these threads will go in parallel like main. Since there are 8 number to count, it may run longer than the C1. And when it is starting all these callable thread, that time itself main thread provides a placeholder. Result list.add is there, right? So that means there are 7 objects here, and this are all simply a placeholder. Result list.add executor.submit task, right? Result list of type future integer add, and its return value we are storing. So it return value is integer, but it's a future object. That's why here, even though we are making add method here we will be getting just a placeholder without any value. So this placeholder will be used by the caller thread later, and it will fill the content, right? So main thread execution is still going on, and at some stage, if you see, main thread is making call to some ticker task as well. Here, if you see, at a certain stage it spans some ticker task, right? Let's state that T1, ticker task 2, and ticker task 3. That's what happening here, right? So here at stage 1 it spanned all these callable tasks, and it knows the placeholder also. Result list.add, when it is calling this all this, it provides the placeholder, or it fills the placeholder array with the future, and the execution is going on here on this callable thread. In the meantime, main thread is going on proceeding. It will not wait here for this executor submit task to complete. So since it's a threaded task, it will immediately move here and it spans this ticker task, and it further moves here after starting the ticker task and iterates through this list. So now at this stage, let's state that this is a stage 3. At stage 3, this will come back and iterate through the future object to read the summation list, right? So let's state that when after starting all this ticker task, when it is coming back, since the summation is less here in the initial stage, we will assume that future object is filled for 3 slant. The main thread will read all this and display that, and when it is reading the 5th one, let's state that result is not yet arrived. It is still, computation is still going on, and the main thread will wait for the result and it will print the content once it arrives. Then it goes to the next slot, it will wait and prints the content. So that's how this example works. This one. So this is the blocking called get, right? So it will wait for the get. And if you see the result is populated by this callable object. Callable object will write the result. Right? Once callable task finish, it will fills the placeholder, and when main thread is finished its task, it will examine the placeholder and reads the value, prints the summation. Here get, right? Get will give us the future object, and using that here we are printing the result. All right, now let's go ahead and implement the example. Now we will create a class ex06 ticker, or we can even make use of ex05. So let's create the duplicate. Okay, since implements runnable. So this was already explained to you. In the constructor, we are setting the end as well as name and running the loop till the end. So this will just print the message in the console window. Now we will go ahead and implement the summation task. So it's our callable task. Implements callable v will be here integer. So if callable object returns something else, you have to provide that type here. Our example returns a summation of numbers, so we provide integer. Implement all abstract method, and you will be seeing public integer, call, throws, exception, and we will remove this body for now. This is our call method. And you can see the callable import is added. We will hold internal variable to collect the summation. So sum2, we are initializing it with the end, and this declaration is not required, or initialization is not required. Anyhow, that get initialized in the constructor. So here we perform the summation actually. So this is our callable task. And if you see the difference, callable task returns an integer. Just like ticker task, this is also spanning a loop, but it calculates the summation and finally returns the sum. And sleep time we are increasing for each I into 20. So if summation is 8, then we intentionally make that callable task to run longer time than the first callable task. So that will do only one summation, and if it is a second one, that will perform 2 summation. So first time the delay will be 200 milliseconds, second time it will be 400. But when we make a call to summation of 8 numbers, there will be more sleep. So we are just mimicking that the callable task on later stage takes more time, so that we can examine how main thread come back after starting the ticker threads and wait for future object. There will be some future object that will be ready, but some future object will not be ready. It will wait on the get call. Alright, so the callable task is ready at this stage. Now we will go to our main entry, our main thread. In the main thread, we will remove our previous example code. Remove all unused imports. We will add it on need basis. So linked list Java util concurrent future object. Then linked list, we need to collect it from Java util. Execute service, again from concurrent. Execute as, that's also from Java util concurrent. So at this stage, if you see, we are starting 7 callable task, right? Executor.submit task, and the task is here. We are starting ex06 summation task is defined here, that implements callable. So finally this will be the threaded call which returns an integer. So this is running in main thread context, right? First it is calling some callable task, and when callable task is executing, in the meantime the main will not wait at this stage. Executor.submit, it will keep on submitting 7 tasks. After that, it will not wait for the execution. The task will go in parallel. In the meantime, main will come back here and performs the ticker execution. So this time I'm throwing interrupted exception at main itself. This may not be a good practice, but that's okay for now. So this is spanning a 3 ticker thread. So it may take some time for the main, and during that time maybe 1 or 2 callable thread completed, and result will be available in this future linked list. So now we will iterate through that. So iterator is from Java util iterator. concurrent execution exception. That's all. Here okay, we are iterating through the future object. As next, all these stuffs are collection based code. It is simply iterating the linked list, right? Linked list of our future integer. And what is important is this get method. So when iterator next returns a future integer, from that we are making call to get, and this future integer is a placeholder object. It make it filled by the callable thread, which is the summation task, and by the time when we are iterating here, if the future object is ready, the get method will return immediately. So for first 1 or 2 or 3 callable tasks, we may see the result immediately, but for other summation task 5, 6 or 7, we may need to wait on this get call, because the callable thread is still doing the summation. And when we are going through the example, that time you can see that. So the get method will return the placeholder value, and we are printing that in this println statement. So while loop is ending here, right? We will finalize our example. So thread pool we are shutting down, that's all, and finally we are stating that a main thread ends. We will rebuild this and see how it executes. All right, let's run it. And if you look at the output, main thread starts. Main thread is submitting the task, right? Here if you see, main thread submitting summation task for 1, 2, 3, 4, 5. Before it submits 6 and 7, since these are callable threads, you can see some 2 started first, some 1 is started later, and some 3 is started. Here main thread also running in parallel, and it is starting some 7, and you can see the summation threads are running here. In the meantime, main thread is going and starting the runnable task, that's the ticker task, and here you can see ticker also running in parallel, ticker 1. Someone ends at this stage, ticker 1 is printing its next count 2. Main thread starting runnable task 2, sum 2 ends by this time, ticker 1 is going on, it is doing the third count. Main thread starting runnable task 3, by this time sum 3 ends. That means summation is available for task 1, 2 and 3. That means the future object slash for 1, 2, 3 is ready. So ticker thread is going on, and you can see main thread is printing the summation 1, 3, 6, 1 for summation 0, summation 1. For summation 2 it will be 2 plus 1, right? 3. For summation 3 it will be 3 plus 2 plus 1, 6. 3 results are readily available, and we saw that here in the console itself, sum 3 ends, sum 2 ends, sum 1 ends, right? So it is collecting those from the future object. In the meantime, sum 4 also ends. Ticker is running in parallel. Ticker 1 finished its counting, ticker 2 is starting its count, ticker 2 running in parallel, and main thread is collecting the future object because 4 ends here, right? And you can see ticker 2 is running in parallel, and sum 5 is ending, so summation is printed, ticker is running on, sum 6 ends, main thread prints the summation because main thread also doing the iteration, right? And if you see, there are multiple tasks running in parallel. One is the summation and another one is the ticker, and you can see in between ticker also popping up and printing its result. And some 6 ends, and if you see ticker 3 also finished its job, but some 7 ends towards the end, because that takes more time to count summation. We simulated it like that because there will be more delay for summation 7 and 6, all those stuff. And the main thread is waiting here, and once the sum 7 puts a content into the future object, main thread prints the result. So if we run it multiple time, there may be slight difference, but it works. The main thread waits for the future object and prints and puts the same result, I mean the summation result. Alright, that's all here. We have to shut down this summation pool also, since the video is running long. We will be closing it. Just now you saw the demo of how we can start the callable thread and collect the future object in later stage using the get method. Thank you for watching. Bye.